Hello, I welcome you all in this course on the joining technologies for the metals. This is the second presentation on the same. In this presentation basically I will talk about the fundamental mechanisms of the joining, fundamental mechanisms of the joining. Then we will see that for the joining purpose basically we use heat, pressure and filler. So, what is the role of the heat, pressure and filler in the joining processes? And then based on this since over a period of time lot of the joining processes have been developed. So, how can we classify? But before going into the basis for the classification, we will try to see the need for classification. So, the need to see the classification of the joining processes. So, these are the four aspects that we will try to see in this presentation. So, this presentation basically involves the fundamental mechanisms and the need of classification, role of the heat, pressure and fillers, classification based on the two aspects. One is like say the technological factors, which is basically in form of those technical aspects which are used in the joining processes, like whether the filler is used or not, or whether the pressure is used or whether the pressure is used or not, the kind of energy which is being used, with the source of the energy for the welding purpose. Then there is whether arc is there or no arc process, and then there is the pressure and the fusion. So, these are basically the technical factors, that whether the pressure is being used or the melting is achieved, whether arc is being used in the joining process for developing heat or not, the kind of energy which is being used, or whether filler is used or not. So, the classification based on these are the technological factors. Then we will see that the approach being used for the joining purpose. Approach means that how the joint is made. So, that how the joint is made basically involves whether it is a cast weld process, or it is the fusion based process, or it is a solid state based process, or the resistance heating is involved. So, these are the four ways by which the joint is made. Here in the cast welds processes, molten metal is fed at the fin surface, between the fin surfaces to be joined. So, this is the entire coverage of the presentation. So, we will see first the mechanisms which are used for the developing joints. Basically, there are three mechanisms which are used for developing the joints. One is like say the deformation, where the interfacial or the bulk deformation is used. So, this deformation may be with recrystallization or without recrystallization, with or without recrystallization. So, if the second one is like the diffusion. So, the diffusion at the fin surfaces, which may be done with interlayers or without interlayers. And here sometimes the diffusion accelerators are used, diffusion accelerator or accelerating approaches are used, like pulsing pressure or ultrasonic vibrations are applied. Third one is like the melting or the fusion of the fin surfaces involving direct solidification, direct growth through the epitaxial mechanism, or the second one is like the nucleation and the growth mechanism is involved. So, each of these elaborate one by one, like say the two components having the regular arrangements of the atom like this, and this is the interface. So, this arrangement of the atom here existing in this way the sides, and when the joint is made, you will see this arrangement of atoms is disturbed in this manner, where the continuity is achieved, but the arrangement of the atoms near the interface is disturbed. So, like here they are like this, but here as soon as we approach towards the interface, the arrangement of the atoms or orientation of the atoms in the lattice gets disturbed. So, here it will have the strained lattice with the distorted or the disturbed arrangement of the atom. So, this is the approach where without recrystallization. So, no crystallization, this is the case when the atoms or the regular arrangement of the atoms is distorted when the metallic continuity is achieved, and if the recrystallization is involved, you will see that the joint is continuous and the arrangement of the atom is still maintained even after the welding, because the fresh grains are formed and there is no lattice strain. So, this happens when the lot of heat is generated in course of the welding, and here the heat generated is limited. So, these are the deformation based joining processes where heat generation is limited. You will see that strained lattices and disturbed arrangement of the atoms, and otherwise when the recrystallization takes place, the deformation with the recrystallization, when sufficient heat is generated, the normal arrangement of the atoms is achieved. So, you will see that there is a joint, but the arrangement of the atoms have not been disturbed much. In the diffusion, in case of the diffusion, the components to be joined in very clean polished condition are brought together and they are kept under pressure, usually in the vacuum, maybe it may be in active or inert environment also. So, when there is direct metallic intimacy due to the concentration gradient of the elements across the interface, the diffusion starts across the interface. So, this diffusion has to be the diffusion is facilitated basically by the temperature over a sufficient period of time. So, when the sufficient time and temperature is given, the bond at the interface is formed. So, to facilitate the diffusion across the interface, sometimes to overcome the problems related with the surface roughness, interlayers are used, interlayers of the soft metals are used. So, under pressure they get deformed and fill the cavities and irregularities present at the surface in order to facilitate the diffusion across the interface, and sometimes the pulsating pressures are also used, so that the peaks and valleys get collapsed under the pulsing pressure conditions and bring the metallic intimacy in the firm contact with each other. So, similarly the use of the ultrasonic vibrations also help in facilitating the diffusion across the interface, so that the diffusion bond can be developed at much a faster rate. The melting of the fusion based approach, where the components to be joined are brought to the molten state. So, these are the two members. So, in case of autogeneous weld, just the edges of the component to be joined are brought to the molten state and the metallic continuity is obtained. This kind of the joints are called autogeneous weld, where just the melting of the Feng surface is achieved, and after the solidification we get the sound weld joint. And when the larger, when the greater thicknesses are to be joined, then the groove is usually made, and this the groove is filled using the filler. Filler may be of the same composition as that of the base metal or of the different metal. So if it is of the same, if the filler used same as base metal, then again epitaxial solidification takes place. But if the filler metal is different from the base metal, then the nucleation and the growth mechanism of the solidification is involved. So this is these are the approaches which are used for developing the joint. For example, for this case, like in the laser welding or in tungsten inert gas welding process, where thin sheets of say 3 mm, 4 mm are brought to the Feng surface, are brought to the molten state, and then after solidification we get the joint. So just melting of the Feng surface is achieved, no filler metal is used in these situations. But for specific requirements, sometimes what we do, that the components to be joined are are welded using the filler of the different composition. Like say in case of the cast iron, it is common to use the nickel as a filler metal. So here it is a completely different. This has like say cast iron has a BCC structure, and the nickel has the FCC structure. So that because of significantly different use of the filler metal, first the nucleation and then growth mechanism is involved in course of the development of the welded joints. So whenever the fusion is the joining mechanism, you will see that either the epitaxial or the nucleation and growth mechanisms are involved for completion of the solidification. So these are the fundamental mechanisms. So if you will see here, these three mechanisms will be using either the heat or pressure or both. So the different processes will be using different processes of the joining will be using either of these three, one of these three mechanisms for developing the joints. Since the deformation, diffusion and melting, these are the three things which are there, they will use pressure, heat and filler, either singly or in combination. So using these three fundamental aspects, the different range, a very wide range of the processes have been developed over a period of time. So over a period of time you will see that a very large range of the solid state joining processes, a very large range of the solid liquid state processes and the liquid state processes have been developed. So in order to understand clearly for better communication, it is required that they are classified appropriately. So as we know that the entire range of the joining process we can put in three categories involving the chemical or the adhesive joining, involves the chemical interaction with the surfaces like the soldering, brazing, and the adhesives are used. The mechanical joining, where use of the rivets, nuts and bolts, or the press fits arrangements are used, or the welding involving the solid state, liquid state and the solid liquid state. In solid state, the process like friction stir welding or the friction welding processes or the forge welding process, liquid state process where the fusion of the Feng surface is achieved for melting purpose, and the solid liquid processes where the base metal remains in the solid state and the filler metal in form of the solder or the brazing material is brought to the molten state to develop the joint. So, since the range of processes in each of the category is very wide, so we need to see the really how the different processes can be grouped. So, the grouping is to be done for the specific purpose. We have seen that the joints using these three fundamental approaches can be developed with or without use of heat, or with or without use of pressure or filler. And since these are the three fundamental things features which may be involved in the in one or other joining processes. So, since the existence of the very wide range of joining processes is there, so we need to see really how the grouping of the different processes can be done. That is what is called the classification. So, as far as the need of the classification is concerned, we need to see that how the different processes can be grouped at one place based on their fundamental similarity or the dissimilarity. So, the one reason is to need to classify is that we want to see that how the grouping of the different joining processes is possible based on the fundamental similarities or the dissimilarities. We can organize the different joining processes also effectively if they are classified properly. So, organization means all solid state joining processes, or the resistance welding processes, or the fusion welding process, or arc welding process. There can be so many ways to group or the classify the joining processes, and then easy to communicate, like this category of the metals will be subjected to solid state joining, or this category of the metal will be subjected to the, or this dissimilar combination will be subject to the like the solid liquid based processes because of the metallurgical incompatibility. So, depending upon the requirements, we can use the different kind of processes in the different categories. So, important thing is like our communication to use a particular kind of the joining process becomes effective. That is what is there, easy communication, and then easy nomenclature. Nomenclature means under what conditions the joining process is being done, that can be used as a basis to classify, like solid state joining processes, or liquid state, or solid liquid state, or the process is based on the arc, like that. If some hybrid joining process or the newer joining process also have been developed, naming would be easier based on the fundamental aspects related with the joining process. So, the classification also helps in effective and the proper nomenclature. These are the 3 or 4 purposes because of which, 4 reasons because of which classification actually help in realizing these points. So, now we will see that since the use of the heat, filler, and the pressure is very crucial in joining, irrespective of the kind of process which is used. So, wherever these 3 things are involved, what is basically the purpose? In general, wherever the joining process is involved, joining process is whatever the joining process is, it will be using either the pressure or heat or the filler in singly or in combination. So, the specific purposes of the using heat, you will see that there are 3 or 4 purposes. First is that whenever heat is applied, it helps to clean. So, the cleaning of the fine surfaces of the base metal or of the substrate. So, basically it evaporates, or evaporation of all organic impurities, maybe in form of oil, paint, or moisture. So, all these things get evaporated, moisture, oil, paints, etc. all these things get evaporated. At the same time, some of the things get decomposed, like some of the oxides of the titanium and copper oxides, they get decomposed. Oxides get decomposed, and so they are removed from they get destabilized, and they can be easily means removed from the surface. Decomposition, and sometimes the fracture of the brittle oxides, also takes place due to the differential thermal expansion behavior. Oxides do not expand that much as compared to that of metals. So, the differential expansion behavior leads to the fracture of the brittle oxide. So, that is how the cleaning the heating helps in cleaning of the metal. Once so this is one, the big factor. The second one is the application of the heat helps to lower the yield strength of the metal. So, reduction in yield strength sigma y of the metal helps in, it helps to facilitate the deformation. This deformation in some of the processes is used interfacial, and some of the processes it is bulk. So, interfacial deformation like the ultrasonic welding process, or the bulk deformation like friction welding and friction stir welding process. So, the interfacial or the bulk deformation. Sometimes heat is intentionally generated, so that generated and applied, so that the yield strength of the metal can be reduced in order to facilitate the deformation, so that the metallic continuity is achieved. This deformation can be at the two levels, one is interfacial or at the bulk level. Third is to see that the dynamic recrystallization, whenever heat generated is enough. So, due to the deformation, when the lattice is disturbed, at the same time you will see that the fresh grains are formed in the deformed material with the help of the heat being applied. So, the dynamic recrystallization is also achieved. Now, the fourth important purpose, you know that the diffusion rate increases with the increase in temperature. In order to achieve the develop the diffusion bonds in reasonably good time, the high temperature, the temperature high enough like say 0.5 to 0.6 times of the melting point in Kelvin is normally achieved for by the heating. So, basically the purpose of heating sometimes is to accelerate the diffusion, especially in the diffusion bonding process, accelerating the diffusion, so that the diffusion bond across the interface can be achieved if easily. And the last one, the next one more purpose of applying the heat is like for achieving the fusion of the fairing surfaces, so that the metallic continuity can be achieved. So, here these are the 5 purposes of applying heat, and the most commonly all fusion welding processes will be using the heat for the melting of the fairing surfaces. At the same time, this is also used for the melting of the filler metal. So, the processes like brazing and the soldering will be using the heat for the melting of the filler and marginal heating of the base metal, but in those cases the base metal remains in the solid state. Now, we will see the purpose of the pressure for which it is applied. The pressure in the joining processes is used for the different purposes than that for the heat is used. So, the application of the pressure helps in like the purposes for which pressure is applied. One is it is just like disrupting the adsorbed gas layer. We know that all the real components are made of the number of, like this is bulk, this is the deformed, then oxide layer, and then absorbed gas layer. So, oxides, the thickness of these layers may be in very nano level or in the micron level. This is a deformed layer, this is the base, and this is the adsorbed. So, the surface at very top of very few nano meters is very small, having the gases absorbed from the atmosphere. So, with the application of the adsorbed gas layer is disrupted or broken down with the application of the pressure. Then fracturing of the oxide layer, that is also achieved when the pressure is applied. So, the metallic intimacy between the fink surfaces is achieved. Intimacy between the fink surfaces is achieved, and one more purpose is to achieve the deformation as per requirement. This deformation may be interfacial or it may be bulk. Interfacial deformation, as I have said, is achieved in case of your the ultrasonic welding process and the explosion welding process, and the bulk deformation is in friction welding and ultrasonic welding, force welding, etc. So, these are the three purposes which are achieved with the help of the applying pressure, irrespective of the conditions in which joining process it is used. So, one or more purposes can be achieved through the use of pressure in those joining processes where pressure is used as a major variable, and then use of filler. Use of filler is very important, especially in case of the groove welding, say this is used to fill the gap. This is one thing. So, in all consumable welding processes, the filler actually plays one big role of the filling of the gap. This is one thing that the filling the gap in groove welding is obtained or is achieved. The second one is it is intentionally sometimes used of the different compositions to adjust the chemical composition of the weld metal. Chemical composition of the weld metal. Sometimes the base metal becomes very sensitive for cracking, like say the base metal have high solidification temperature range. So, because of the high solidification temperature, it shows the tendency of the for the center line cracks. So, that tendency is tendency for the center line crack is reduced. Is reduced by adjusting the chemical composition of the weld metal in such a way that solidification temperature range is reduced. So, sometimes the filler metal of the different chemical composition is used in order to adjust the composition of the weld metal, so that solidification cracking tendency can be reduced. And then it is also used for achieving the specific properties in the weld, like the filler can be of the different composition than the base for having very good corrosion resistance, or sometimes the filler metal is selected intentionally of the lowest strength. So, the residual stress magnitude, lowest strength and high ductility, so that the residual stress magnitude can be reduced. So, improving the corrosion resistance, reducing the residual stresses, and having the desired combination of the strength. Sometimes the filler metal is selected in such a way that they are much higher strength or much harder, of much higher hardness. For say for wear resistance application, where it is possible that the weld can erode. So, the high hardness the filler metal is added. This will help in reducing the wear resistance, improving the wear resistance of the filler metal. So, in this lecture we have seen that the different joining processes can be categorized based on the fundamental mechanisms. There are three fundamental mechanisms. One is like diffusion, another is the deformation with or without recrystallization, and third is fusion. And this is achieved through the proper application of the heat, pressure of filler, either singly or in combination with the other, and each of these three factors play a very important role whenever they are used in the joining processes. So, in the next presentation I will talk about the different technological factors which can be used for classification of the joining processes. Thank you for your attention.